What are dependent events? Jalen, what do you think? What do you think a dependent event might mean?
I'm not sure, but I would guess.
Okay, I like that. You have an excellent mathematical mind. So I'm sure you'll come with something. Let me hear it. Oh, I can't give up. So tell me, Jalen, what do we say dependent meant? What does it mean if I'm dependent?
Like, you do what everyone else does.
Okay, so do what everyone else. So like my life depends on what you do. Somebody else does. So when we think about probability, maybe it depends on something else that happens.
Yeah.
Yeah, right? So maybe, put your hands up, maybe it depends on something else that happens. Okay, what's the probability of choosing a red and then a red with no replacement? Okay. So let's say, scenario, hold on. Well, sorry, you're right. Anthony, what's the probability that he's going to get a red the first time? 9 out of 19.
Yeah, the second time.
Hold on, let's see. I know you know. Keep that thought in your head. All right, pick 1.5. You gotta be quick, come on. But we don't know that, right? When we are talking about probability, we don't necessarily know what happens, right? Because this is all really theoretical. So he's gonna, before he draws again. Okay? Before he draws again. So now, when we talk about probability, we have the possible outcomes, right? Over the number of favorable outcomes. So first time, we get what we wanted. So if we got what we wanted, what would he really have picked, Anthony? A red. So that he always gets what he wants in the first one. So then in the second one, how many cubes does he now have to choose from, Jalen? 18. And Desiree, if he already took a red one, right? What's the probability that now he can get another red one? How many reds are left in my hat? 8. So now there are
8 out of 18 chances.
8 out of 18. How do you think? So how would we find the probability for this now? We would do what? We would multiply. 9 times 8 is what?
17.
It's 19 and 18. Anthony, I gotta see you working. Come on.
342. Yeah, 342.
All right. What? 36. And 342. Oh, come on.
71.
342 divided by 2.
Oh.
32 is what?
1.
What's half of 34?
17.
And then half of 2 is 1. We're going to be able to do that in our heads. Algebra and high school. Alright, so let's talk about what this really is going to look like when you see it written. So, let me erase all this. And this is the part I want to make sure we get into our notes. Okay? Make sure you get this into your notes. Alright, when we talk about independent events, it says, okay, of A and B is equal to the probability of A times the probability of B. So get that down. Get that in your notes. Okay? We have the probability of A, then B. We get the probability of A times the probability of B. probability of A then B is probability of A times probability of B. Okay. And remember, these are a little different because when they're dependent, okay, when they are dependent events, what happens first matters. So this number will be a little different. In the independent events, right, our denominators are going to be the what? Same, right? So in independent events, our denominators stay the same. So let's do, yeah, quick, supposed to move. So I'm going to ask Denario to come help me, and I'm going to ask Marie to come help me. I'm going to bring some cubic table. Don't throw these around. Just set them on your table for now. We're going to do a couple things together, okay? So you guys are going to give everybody, you're going to give everybody 3 blue, you give everybody 2 yellow. Just grab one, let you take one. While we're doing this, I'm actually going to also come give you the worksheet I want on it. Go ahead and put your name on it. We're going to be on the teaching. You know that's my favorite side to do first. Always. I know. Quick, guys. Quick, quick, quick. Look at that. I had exactly enough. I know. But thanks for the affirmation, Jay. All right. Huh? Affirmation is like when you're
I'm saying all of them too.
high five. All right, so affirmation. You did too? There you go, Miriam. I'm impressed. Yeah. Affirmation is like when you say something, you confirm what I believe, basically, or like a positive statement. All right, so have a seat. Have a seat. All right, let's look at this. On this side, you should have your name on it because that's what I asked you to do when I handed it out. I cannot decipher your writing, even though it's right. So your name's on top. All right. So it gives you some examples. It's just basically what went over the board, and I want you to have that so when you get home. All right. So let's read the directions right above number 1. Jalen, what does it say?
A store has 3 cans of green paint, 3 cans of blue paint, and 2 cans of yellow paint. You randomly choose 1 can of paint and then replace it. Then you choose the second can of paint. Find its probability.
Okay. Great. So it says something really important there. It says something really important that we have to remember. It's not about the number of cans of paint. Desiree, what is something in there that's independent or dependent? What is it? Just give me it. It's right at the end, close to the end there. What does it say? Replace it. So if we're going to replace it, we're going to take a can of paint, and then we're going to what? Replace it. And put it back before we choose again. What kind of event is it?
Independent.
Independent. You're right. It's an independent event. So let's. I know they're not. They're cubes. But whatever. They're cans of paint. We have good imaginations. So the first number 1 says, "What's the probability of?" Okay. So Anthony, what's the probability of getting a green?
3.
3 out of how many?
8.
We're going to multiply that by, what's the probability? See, it says green, then yellow. So, Duran, what's the probability we get yellow? 2 out of 8. So what would we get when we multiply?
6 over 64.
6 over 64.